Hey there, I'm srcmake and welcome to the video on reversing a linked list. And in this video we are going to go through 3 layers of difficulty and they all happen to be Leetcode problems. So we're going to run our code on Leetcode to make sure that it works properly. So in this video we have got the easy problem, which is reversing a linked list. We'll talk about that problem. We will go over the solution with the iterative approach, which is the best one. And then we are going to look at this diagram that I made to understand what's going on in the algorithm that we chose. And then we've got some C++ code here that we'll quickly talk about that actually implements that algorithm. Then we have got the medium problem, which is reversing a linked list from node M to node N. We'll talk about that problem. We will go through the solution. I've got another diagram here that we're going to go through to make it easy to understand. And then we've got some C++ code that actually implements that algorithm that we'll quickly walk through. It's basically the same code as the easy problem, so that'll be easy. There are just a few minor changes. Then we've got the hard problem, which is reversing a linked list in k groups. We'll talk about how that problem works. We will look at the solution. I've got another diagram here that we're going to walk through so that we understand the algorithm. And then I've got some more C++ code, which basically just builds on top of the medium problem. So if you understand the medium problem and the easy problem, this one is actually like way easier than the rest of them. Once you understand the easy one, everything else is super easy. So after that, we'll just talk about the alternative solutions. For each one of these problems, we'll run the code in Leetcode to make sure that it runs and it's got good time in space on Leetcode. And yeah, so all of these resources, this code, these diagrams are on my website. If you want to get to this webpage and bookmark it so that you can have it later on, feel free to click the link below this video. And while you're down there, hit the subscribe button for this YouTube channel. Thanks. So reversing a linked list, this is a pretty famous question. So the easy problem is, given the head of a singly linked list, reverse it. And so you've got this linked list like this, 1, 2, 3, 4, these nodes. What you want to do is return an updated list, which has node 4 as the head of the list, and it's reversed, so 4, 3, 2, 1 is what gets returned. And so the solution we do is going to be an iterative approach, which happens to be the best one. And so what we do is we iterate through the linked list and we change each node's next pointer to point to the previous node on the list. Basically, we're updating the next pointer instead of doing anything weird, which is actually really efficient. And so to do this, all we need to do is maintain 2 extra pointers while traversing the list. One of them is going to be the previous node that is before the current node, and then we've got the current node, which is kind of how you iterate through a linked list anyway. So let's look at this diagram up close really quickly. I'm going to zoom in a little. This is basically the initial state of the linked list. We've got the linked list right here, and we've got this null node. Our previous pointer is going to point to this null node initially, and our current pointer is going to start at the head of the list. And we've got this next pointer here that's just going to be a temporary variable. We don't need to worry too much about it. And so what we do is, in the first step, we say the next pointer is going to point to current nodes next, which in this case is 2. And then in the next step, we will change the current node's next pointer. It's not going to point to 2 anymore. It's going to point to the previous node. So in this case, the previous node is going to be null. So we point to null. And so in the next step, what we will do is we will update previous. Previous no longer points to null. It's going to point to the current node. And then finally, we are going to make the current node point to the next node, which is stored right here. And so that's basically one sweep of the iteration, the traversal. And so after that, the linked list kind of looks like this. So we've got previous pointing to 1, current pointing to 2, and now there's no more pointer from 1 to 2. Instead, 1 changes pointer to point back to null. And so we kind of keep doing that through each one of these until the list is entirely reversed, and the new head is going to be the end of the list, which is going to be 4. Which is kind of easy once you visualize it like this, but to understand that from scratch is like really hard. So let's look at the code. C++ code written right here. You've got these 2 pointers, previous, which starts at null, current, which starts at the head. We have a while loop that continues on while we continue to have nodes. And we've got like 4 lines of code, really simple. Temporary variable for next. We change the current node's next pointer to point to the previous node, and then we update previous and current for the next iteration. Really simple. So I'm going to copy this code right here, and we're going to paste it into Leetcode. This is the problem. You can find it on my website on the page. There will be a link. I hit run code, and it compiles. You can kind of see accept. I zoomed in a lot for this. You can see I did this one a long time ago. Let's hope we get good results again. And 94% is basically as good as we're going to get. So that's great. 94, 100, great. So now the next problem, oh, and the time complexity for the solution is order n because we visit each node in the list just once, and the space complexity is order 1 because the only data we have is like those 3 pointers. There's nothing extra except for the, those 3 pointers. So the next problem is the medium problem, reversing a linked list from node M to node N. So in this case, for Leetcode specifically, they've got these nodes and they're labeled with these integers, and so they consider node 2 and node 4 like what we want to reverse in this example right here. They kind of give you the node numbers instead of other things. Like in C++, they could have given you pointers, but in this case, it's numbers. So we've got this initial linked list, and so if we wanted to reverse m equals 2 and n equals 4, which basically means this block right here, everything before that chain and after that chain is going to stay the same, but this ends up being reversed. And so we've got D, C, and B, that's what it becomes after the reversal. And then we've still got A in front of it and E after it. And so let's go through the solution. We're going to do the iterative approach again. The reversing part is going to be the exact same code as before. The only thing we're doing this time is we have to start and stop reversing at specific nodes. We can't just reverse the entire list. We need to start it and stop at specific places. And the other thing is we might be left with some disconnected sublists that we need to rejoin. And we'll see that in the example. So we just need a few extra pointers this time. One pointer is going to point to the new end of the reverse list, and the other pointer will point to whatever before the node before the reverse chain. So we'll kind of see that. We're not going to go through the algorithm steps that I listed out there. Let's go straight into the problem. So I'll zoom in a little bit, and here's basically what we have. So we've got, this is our initial list, A, B, C, D, E. We first move the current pointer to node M. So if we were to traverse through and, oh, here it is. This is node M right here, coincidentally. So current pointer is going to point to here. Previous is going to point to here. We initialize these other 2 pointers. This pointer is going to point to the before reverse. So this is the reverse chain right here. We know that. And this node is going to be the one that will be the node before the reverse chain. And this one is going to be the new end of the reverse chain. So when we reverse BCD, B is going to be at the end, and that's the end of the chain. And we need to know that later because we need to reconnect things. So what we do from here is we reverse this list right here. And so that's going to look something like this. A is going to be over here, and it's disjointed. BCD looks the same, but really, remember, the trick is that we move the next pointer backward. And so it kind of looks like this. D points to C, C points to B. And then we no longer have this pointer here. So we do have this disjoint. And so we need to fix the connections. And basically, since we have these other 2 pointers, we know, oh, we can make A point to D, and we can make B point to E because we have pointers to each one of those. And so now the new list, if you look at it, is A, and then we go over D, C, B, E, which in this diagram, it doesn't look like it's together because remember, we're moving pointers. We're not like switching anything around. We're not swapping nodes, just switching next pointers. And so that is basically the algorithm. If we look at the code, it's like this. The only thing we need to keep track of is for this problem, we need the node number to know which node we are at. And so if the node number, we start out by traversing and making sure we make the current node be the one node M. So again, kind of like up here, we moved current to be over here. That's just what that first step is. And then afterward, we will do our, are we at the right thing? Yeah, we are at the right thing. So right here, we set up the before, reverse, and last and reverse pointers. And then all we have to do is do the reverse, which is the same as before, these steps right here. This time we have to update node number and make sure we stop after we do node N. And then we've got 2 final if statements right here to fix the connections that we showed before. Before and reverse is next is going to be prev, and we do that. That's what the code looks like. You can look at the diagram afterward if you want to know the details. And then the final thing is if we had reversed the head of the linked list, then we have to change the new head to be prev, which is basically like In this diagram right here, if A was also part of the reverse chain, then it would no longer be the head of the linked list. D would be that, and so we would need to make D the new head of the list. So that's the algorithm. That is the code. Let's run it in Leetcode to make sure that it works properly. So I'm just going to copy this, and we're going to come over here, and I'm going to paste it, and I'm going to hit run code. You can kind of see it. I'm kind of blocking it right here, and it works. So now let's submit it. You can see I did this pretty recent, actually. And 100%, 100%. Doesn't get any better than that, 0 milliseconds. So that is the medium problem. The time complexity is order n because, once again, we visit each node in the list at most once. And then the space complexity is order 1 because the only extra data we have, again, is a few extra pointers. So that brings us to the famous hard problem, reverse a linked list in k groups. And so the problem is something like this. The problem is if you have this initial linked list and we say k is equal to 3, we want to reverse it in groups of 3. What it would turn out to be is you would reverse 1, 2, 3. Okay, that's a group of 3, so reverse that. And then you've got another group, 4, 5, 6. Oh, okay, that's another group of 3, so reverse that into 6, 5, 4. And then we finally got 7 and 8. Oh, that group is smaller than 3, so we're not even going to do any reversal, so we just leave that alone. And so the final list would look like 3, 2, 1, which is the first grouping, 6, 5, 4, which is the next grouping, 7, 8. And that's all strung together is one entire linked list. And so this is sort of, it sounds really difficult if you had to do it from scratch, but once you know the reverse technique and the other one that we just did in the medium problem, it's really easy. So this builds on the previous solutions that we just went through. The difference is this time we will continuously reverse starting from the head of the linked list until we run out of k length chains to reverse. So this time we're going to keep reversing. We're going to do k nodes. We're going to reverse them, fix the connections, and then we are going to do the next k nodes, and then we're going to fix the connections, and we're going to keep doing that as much as we can. So the only thing we need to keep in mind that's different is we need to update the previous pointer after each reversal chain because that changes. But otherwise, it's basically the same solution. So let's go through this diagram that I have. I'm going to make it a little bigger, a little bit smaller than that. Okay. So let's go through it. This is the initial state. We've got 1, 2, 8. That's our initial linked list. Current pointer starts at 1, the head of the linked list. Previous starts at null. And we've got this before reverse and last in reverse that we did from the last thing. And so we go through, in this case, k is equal to 3. We reverse the pointers for 3. And this is what it looks like afterward. Current is pointing to 4, previous pointing to 3. And we, in the next step, we fix the connection. So it's a little hard to see. But you can see we have one we're going to make it point to 4. And then after that, there's a few things going on. First is that since we reverse this first, we reverse this head, the new head is going to be 3 because we have to make sure we update the head of the linked list. The other thing is we no longer need this null, so I got rid of it in the picture. So this pointer 1 is going to point to 4. And the other thing we have to do is we have to update these other pointers, So current can stay the same. But now the new previous pointer is no longer going to be 3 like it was over here. Because remember, now before this 4 is going to be 1. That's the 1 before the 4. That's the node ahead of it, before it. So previous is going to be 1. We have to make sure we change that. And of course, we have to update the previous from the new reverse chain and the last in the reverse chain. So this is important. So let me make this clear. Our new next k group is going to be 4, 5, 6. And so when we reverse 4, 5, 6, last in reverse is going to be this 4, obviously, because that's going to be moved over here. And the node that is before this new chain is this one right here, which happens to be pre right now. And so all we have to do is continue those iterations. In this case, we're going to reverse 3 nodes. We change the pointers to point back. That's our trick to do the iterative solution. Current's going to be at 7. It's going to be like, okay, wait, let me stop doing this reversal because I finished that group. Then we are going to fix the pointer connections to make sure that the lists are attached once again after doing that reversal. And then we just update the pointers for the next iteration. But it turns out that we ran out of k groups. The next group, 7 and 8, is too small, so we're not going to reverse it. And so it's just going to look like this in the end. And so the head is going to be 3, and that's going to point to 2, 1. Then it's going to point over to 6. 5, 4, and then it's going to point to 7 and 8, and that's basically it. And so that sounds a little bit difficult, but if you look at the code for it, it's actually really straightforward. So the code is, we want to get the number of nodes in the list so that we make sure we cover that edge case where we don't reverse 7 and 8. It's kind of annoying. It would have been easier to just reverse it, but no, we have to make sure we don't reverse in that case. So just make sure we keep track of the number of nodes left. We set up all of these variables. The only thing that's different is this first group. So basically, you'll see the only reason we care about checking if is first group is because that first group might need to update the head of the linked list. It will need to update the head of the linked list, which is going to be this 3. We've got 2 loops now. We continuously reverse as long as we have nodes left, and we set up the variables, and then we just do the reversal itself. And then same exact code as before, do the reversal this time, make sure we only do it for k nodes instead of just from m to n. And then we fix the connections, and then if it's the first group, then we have to say what the new head is going to be, and then we have to update previous to be the last in reverse, like we talked about, and then we say, oh, well, we did k nodes, so the number of nodes left gets updated. And that's it. That's really simple. It's actually really simple if you know the base problem. It's just a little bit tricky until you draw it out. It was tricky for me until I drew it out. So I'm going to copy this code. I missed one semicolon and a bracket, so I just added them in. It got accepted, so I'm going to hit submit code. 74% is basically as good as we're going to get unless we do some weird optimizations, which I don't really want to do. I want the code to be clean and readable, which is still good. And yeah, that's basically the solution, so it works. So the time complexity is order n because we visit each node in the list twice, once to count the number of nodes and then again to do the actual reversing. The space complexity is order 1 because the only extra data we have again is a few pointers and integers, which is really nice. Interviewers would love that. And so those are the 3 levels of problems for reversing a linked list. So there are other solutions. You could use a stack, but that's not good. You could use recursion, but that's also not good. You could try to swap the data within the node instead of changing pointers. You could be like, oh, let's just swap the numbers, but that's also not ideal in most cases. So that's basically reversing linked lists. We went through 3 difficulties. I really recommend going through this page yourself and looking at the diagrams and seeing if you can do it, because I spent a lot of time drawing this, and it'll be super helpful to make sure you understand it and can actually code it from scratch instead of just, me talking you through it. I just wanted to go through the intuition in this video, but you still need to be able to write the code in interview. So I'm srcmake. Thanks for watching. If you like this video, please leave a comment. If you want to see something else, make sure you follow on Twitter, and I'll see you in the next video.